Hello young explorers. Previous session we saw Fleming's left-hand rule. In this session we will discuss about electricity generator. If you remember, around in 1831, genius Michael Faraday invented DC motor and generator. Actually the structure looks same. If you see this thing, what comes in your mind first? You must have seen this thing in your toys car. Normally you call it as a motor. What is the difference between motor and dynamo? These are the two terms we use. Motor, you have to give external supply to achieve mechanical energy. Means any movement of fan or something. Whereas dynamo, you get electrical current by giving mechanical, means converting mechanical energy into electrical form of energy. So whenever next time you see such thing, before you say it is a dynamo or motor, you have to check few things. And all we know that dynamo or generators are essential part of our life because they generate electricity. And electricity is the most important thing we need today for living. You cannot imagine your life without electricity. This electricity generated at different places. Hydroelectric power plants, atomic power plants, tidal energy, wind energy and solar energy. Except solar energy. In solar energy, we convert solar energy into electrical form of energy with the help of photovoltaic cells. In all rest things, we use generators. And these generators convert mechanical energy into electrical form of energy. There are two different types of generators basically. DC generator and AC generator. We will see structure of DC generator and AC generator and we'll try to understand the difference between these two types of generators and how electric current is induced. Friends, what is this? In normal circumstances, again you will reply this as a motor because such toy motor you must have seen in many toys, cars or any toy where movement is required. Basically, the structure of motor and dynamo, though they look alike, but their function is different. To test anything, whether it is a motor or dynamo, all dynamo can be converted to motor, but all motors are not dynamo. For this, we will do one simple test. Take any one LED and just put two legs of the LEDs to the terminal of this and move first clockwise. Now you will see nothing is happening. So there are two ways. Either this is a motor and not generating enough current to glow this LED. But you cannot conclude this thing unless you do one more experiment or trial. Now I am moving it clockwise. I have to move it anti-clockwise and check. Now see. What is this? When I am moving it anti-clockwise, LED glows for a fraction of seconds. This means this is not a motor, this is dynamo. Means with the help of this dynamo, I am able to generate electricity and can glow one LED. But if you put these LEDs in parallel, you can glow many LEDs at a time. So what is inside this? Let us have a look. For this, I will just use a screwdriver to open it and I will remove this bush as well. Now basically this is a shaft of the motor or the shaft of the dynamo to which we are giving mechanical energy. So you can move this shaft with the help of water, with the help of wind, with the help of tide, with the help of any mechanical energy. So we are able to move this shaft. What is inside this? So I'm just pushing it and taking it out. So here you can see the inner structure. I will keep it aside. This is the connector, and see here what is inside. Now, first of all, see this thing. There are magnets inside. So if I hold it here, there is a strong magnet. So to be a dynamo, this is very important that you should have a very strong magnetic field. After this, if you see it clearly, it's a copper winding, and there are rings here. If you see it clearly, this is a copper ring. This is actually called as a split ring, because this ring is not continuous. It has a gap here. So these are two half curves and they have gap in between. This is a DC generator because it generates electricity only in one direction. So either you move clockwise or anti-clockwise, it generates electricity. But most importantly, you have to remember what is electricity. Electricity is nothing but a flow of charge or flow of electrons. And why electron moves? This is basically called as a electromagnetic induction. So there are two possibilities. Either you move copper coil or conductor in magnetic field, you will get current, or vice versa, you move magnet, still you get current. In this case, what we are doing is we are moving conductor in the magnetic field. We are moving conductor in the magnetic field. So either you move magnet or you move the conductor. In both the cases, electricity is generated. And here, again I will show it by inserting it. This is a very strong magnetic field is here. So I'm not able to, okay, now if I release it, you will see it will jump in because of strong magnetic field. And at the end, whatever electricity is generated, it is connected to these rings, and these rings are attached to the carbon brushes. So here you will see these two carbon brushes touching each other. They have very high, large surface area, and you can split it here like this. So just I will show it to you. It will hold it like this. Like this it holds. Now I will again put this. Also you can open any of the, also the structure of motor, inner structure of motor is again the same. But in motor, these number of turns of copper coil are less and magnetic field is also weak. So in motor what happens? You give external supply, electromagnetism is produced here, and that get interacted with the permanent magnetic field, and motor gets rotation. That is Fleming's left hand rule. Here in DC generator, we are giving external force, means we are giving mechanical energy and getting converted into electrical form of energy. So in this model, we will do a comparative study about how exactly DC generator works and how exactly AC generator works. For that you can see a galvanometer here. With the help of galvanometer, we see current induced in the conductor. These are two magnets. We have a copper coil winding here, and there are few connections. So first of all, I will show what we have done. Here I am moving it slowly. You can see this gap. Basically, this part, this thing and this thing together forms a DC generator. In DC generator, I told you these are called as brushes and these are split rings. Split ring means if you take, for example, this is the copper plate, and if you attach it here, you have only one gap here. This is not split ring, this is a slip ring, which we use in AC generator. In DC generator, it's a split ring, means there are two plates attached in this way. So in half turn, they are disconnected from both the sides. So such a structure is here. And when you move, now I will connect wires to check how much current is induced. Now, first of all, I am moving it clockwise. You have to pay attention to this thing, galvanometer. Now, I am moving it clockwise first. So, when I move clockwise, you will see this galvanometer goes to this your left hand side. Means this current is induced, but it is coming back again to zero. So, as long as you are moving this thing, this is the amount of current you are generating continuously, but this is only in one direction, like this. So if I stop, it will again come back to zero. What will happen if I move it anti-clockwise? Let us check. If I move it anti-clockwise, it is going in the opposite direction. That is why we say DC generator are having polarity and that current flows only in one direction, like this. So this is the working of DC generator. Remember, DC generator have split rings. Now coming back to this part, these two rings and again the magnetic field and copper coil. So I am just change the connections here. Now here what we have done, in this thing, these two brushes have contacts with two different rings and they are called as slip rings. They are called as slip rings, and all the time they are touching with the brush. Here what happens now, pay attention here. As soon as I move clockwise, what happens first? Let us see, I am moving it clockwise, I am giving a jerk. So if I keep moving, see what is happening. This means that current is changing its direction as it is going this way, again coming back to zero and again coming back to opposite side. It means current is changing the direction. But the first position you remember again, as soon as I move clockwise, where it goes first, on this side or on this side, so left hand side. Now again I will move it anti-clockwise and we will check where it goes first. See, though the starting position is different, but when you move continuously, here you are generating AC supply with current changing its direction 50 to 60 times a second in real generators. So this is how AC generator works, and we are also going to make a simple model of AC generator. But before this, we will understand what is Fleming's right hand rule. So what are the differences between AC and DC generator? You have seen the direction of current. In AC generator, the electrical current reverses direction periodically. Whereas in DC generator, the electrical current flows only in one direction. Commutators. AC generators does not have any commutators, whereas DC generator have commutators to make current flow only in one direction. In AC generator, we have slip rings, and DC generator, we have split rings. The output voltage in AC generator is very high, and the output frequency varies mostly from 50 Hz to 60 Hz. It means electricity changes its direction 50 times to 60 times in 1 second. That is why we call it as a 50 hertz, 60 hertz. And in DC generators produce very low voltage as compared to AC generator, which is constant in amplitude and time, and output frequency is 0. When it comes to maintenance, all our generators which we are using to get electricity at home, those all are AC generators. And you must have remember, Nikola Tesla is the person behind design of AC generator, and he was very much in favor of AC generator because he knew the power of AC current, which can be distributed to a very long distance with high efficiency. So when it comes to maintenance, AC generator requires very less maintenance and they are very high reliable, whereas DC generators require frequent maintenance and they are not much reliable. And as I mentioned, distribution and transmission, AC generator is easy to distribute using transformers. You must have seen the transformers in substation or outside of your society. They are step down transformers, because when electricity is generated at the power plant, voltage is very high, some lakhs of volt, and when that electricity reaches to your house, it is 230 volt. So we use two types of transformers, step up transformer and step down transformer. And DC generator is difficult to distribute as transformers cannot be used. If you see the history, Edison was in much favor of DC distribution channel. And there is a famous debate in history between Nikola Tesla and Edison. Edison was not in position to accept Tesla's suggestions, but finally he accepted his mistake, and today all we are using is a AC transmission and distributing AC current. These are very high efficient AC generators, and DC generators are very less efficient due to sparking and loss in copper and eddy current. So we will see in detail about Fleming's left hand rule before we move to our working model. So what is Fleming's right hand rule? In previous session, you learned about Fleming's left hand rule. Let us revise Fleming's left hand rule. If you hold your fingers like this finger represents the direction of current. If current is flowing in this direction, you get magnetic field in this direction and you get a resultant force in this direction. If you remember and understood the Fleming's left hand rule, right hand rule is very simple. It's just a mirror image of left hand rule. In both the cases, this finger remains the same. Only in left hand rule you give current, whereas in right hand rule in generators the current is induced, current is the result. So this we will begin right hand rule with this thumb. This is the direction of conductor. So if conductor is moving in this direction, you get a magnetic field in this direction. As a result, induced current. Remember the word induced current because we are generating current here. So the direction of induced current is like this. So if you hold it like this, then direction of current will be like this and induced current will flow in this direction. Whereas in left hand rule, your movement is result, here induced current is result. This is all about Fleming's right hand rule. This is the generator model you are making today. Here you will see magnets are moving in the coil. In previous model you must have seen that copper coil is moving in the magnetic field. For you, we have designed this generator that we are moving a magnet in copper coil, and you will see the result, LEDs are glowing. And even if I change the direction, still current is generated and LEDs are glowing. Now look at this image of electric AC generator, there are two slip rings R1 and R2, and there are two brushes B1 and B2, and this coil is moving in a permanent magnetic field. Remember these 4 points A, B, C, D. When current is generated, current is flowing from A to B and C to D, and it is reaching to brush which is attached to the electric galvanometer to check current is generated. So according to Fleming's right hand rule, electric current is produced in the branches AB and CD in the direction A to B and C to D. Thus, the current flows in the direction A, B, C, D. You can see this in the image. In the external circuit, the current flows from B2 to B1, brush number 1 and brush number 2, through the galvanometer. If instead of one loop coil, a coil consisting of several turns is used, the current of magnitude several times flows. After half rotation, the branch AB takes place of branch CD, and the branch CD takes the position of the branch AB. Therefore, induced current goes as DCBA. I repeat, DCBA. But the branch BA is always in contact with brush B1, and branch DC is always in contact with B2. Hence, in the external circuit, current flows from B1 to B2, that is opposite to the previous half rotation. This repeats after every half rotation in alternating current is produced. This is what is called as AC generator, and you see the diagram. Now, can you draw the diagram of DC generator and explain it to others? So kids, let us make our own working model of AC generator and have a fun. This kit is to make working model of AC generator. In this, we have two bobbins. I will first take out all the material. So you can see the complete material here, of course, and a wooden base. So we have two bobbins, one with insulated copper wire and one without insulated copper without wire. Then wooden batten, LEDs, strip, nut bolts, brackets, magnets, rubber band, foam, a pulley, screwdriver. Your big task is to put wire on this bobbin from this first bobbin. So if you see this is very thin wire, but this wire is insulated copper wire. It has an insulation cover on it, and you will find one free end here. So just take out that free end from the hole like this, and now you have to turn this wire on to this empty bobbin. But how to do that? For that, what I will do, I will take this empty box and I will place this bobbin here in the box. Now keep this around 6 to 10 centimeters of wire away from this and start winding onto the bobbin like this. But when you are binding, what you have to do, you have to do it cross way. So this turn I am taking from this side of the straw, and this turn I am putting on this side of the straw. So likewise, alternate you have to do. From now I am taking from this side. So go on doing this until another bobbin gets empty. So you have to do this winding. It will take a lot of time for you, but this is the work where you have to keep patience, and also your skills are very much important. Make sure that you do not break this wire in the middle. Otherwise, you have to do the whole work again, or else you have to get new wire. Of course, you can connect this wire in between, but that will be a very skilled work one has to do. So you can now see this wire is from this side of the straw and from this side of the straw as well. So go on doing this work until this another bobbin gets empty. Continue this work. Now I have finished almost 500 turns of this wire, and now you can see I have two free ends of the wire. This wire, clearly see the bobbin from this angle. We have copper wire turnings on both sides of the straws, and we have two empty ends of the wire. Now here you have to do a skilled work. We have to remove coating from the wires, but before that, what you have to do, one end is actually locked. This is the starting end, so it is not coming out, but this free end, it might again come out. So what I am doing, you can use a sellotape and stick sellotape here so that this wire will not come out, and also you have to make sure that both the wires should not touch each other. Now we have to remove insulation from this two ends of the wire, but while removing insulation, you have to make sure that you are removing insulation from all the sides of the wire, and you don't need to take out the insulation from this end. Only 1 or 2 centimeter is sufficient. So remove insulation from front 1 to 2 centimeter, but from all the sides. You can use polish paper. So just I'm showing it onto the board. Hold the wire and remove insulation like this. Now one end you have removed, so turn the wire, and from this end remove the insulation. This is one way of doing using polish paper. If you see the difference, it is a shiny copper wire. So make sure that you can see a shiny copper wire from all the sides. There is another way using a cutter. So, but be careful while you are handling the cutter. So I am showing that cutter as well, using cutter how to remove the insulation. This blade of the cutter is not on my finger. It is actually on the wire. So there is no harm to my finger. I am just holding it in between my finger and the blade. So remove the insulation from all the sides. The only way to check that color of the copper wire changes when insulation goes. You will see a shiny copper wire. So this is our copper turning bobbin is ready. In this step, we will remove this release paper and we'll put it on 4 corners. After this, we have to fix this wooden batten onto this board. If you see this wooden batten carefully, you have these 2 holes here and one big hole on this flat side. We will use this 6x19 screws. So insert these screws from the bottom side like this. One extra screw is given, and if you turn it upside down, you have to match these 2 holes with the screws, but at a time you will tight only one. So hold it from this side, use a screwdriver and tight one by one. So So before, I will just use my finger to tighten it so that it will go inside a wooden batten. And now you can see from this side I am holding this from another side with my hand, and from the other side I am using screwdriver. So fix both the screws. In this step we have to fix this pulley with handle with this batten. So remove the nut from the bolt and washers. From the outside, this is the outer edge of the board. This handle will come on outer edge. So first of all, insert one washer in the bolt. Then insert this bolt from this handle side like this. So handle is on this side and we are going to fix this here in this way. But before that we will put one more washer. Then insert this through the hole. Now here you have to see if you can see this gap clearly. You have to maintain some gap between this wooden batten and pulley, because we don't have to tight this pulley with the nut and bolt with wooden batten. This should move freely. That is our aim. So you have to create some gap here. And now using these two nuts, actually we have to make a lock nut assembly. I will tell you how to make a lock nut. So when you tighten it, if you go on tightening it, this will be fixed. So don't tighten it too much, this nut. Make sure that this is moving freely. When this is moving freely, then take another nut, put it inside. Now here how to make a lock nut. Now if you see, if I am moving this one nut, it is pushing another nut as well. Here what you have to do, the outer nut you have to move clockwise and the inner nut you have to move anti-clockwise. So I will use this angle. So they will get locked with each other like this, and now you can see it is moving freely. So these two nuts are locked with each other, and this wheel is also, or this pulley is also moving freely. This is our goal while we are making this assembly. Here we have to fix these two L brackets in these two holes on the wooden base using nut and bolt. Now what we have to do is, this side of the L bracket will go inside. So insert bolt like this, and from the bottom side, here you may find it difficult, so you may remove this tape for a while and tighten it using screwdriver. Make sure that this should be straight, and then again I am putting this foam. Same from the other side. See here, this flat base are facing each other. Make sure that those flat base are facing each other. Put the nut and tighten it using screwdriver. While you are tightening, make sure that you are holding that nut. Always remember this, you are holding this nut and using screwdriver like this. So I am just keeping it again. So this is our base ready. Now we will fix this bobbin in this L bracket structure using this spoke and pulley. So remove this bush. Remember, this pulley should come on this side. So insert it from the top hole, and we'll keep this bush later. Remove bush from the other side as well. Insert this bobbin like this. It will come from another side. Now we have to insert this spoke through this hole. For that there are two ways. Either you can shift this spoke to this side by pressing it like this and insert this into the hole like this, and again press the spoke and shift this pulley in this line. So these two pulleys are in one line. Also in the middle, if you can see, this orange straw should not come here, because here we have to fix the magnets. So make sure that here space is there, straw is not coming to touch each other. After this, fix, oh, before that I forgot one thing. So what we need to do is, again I have to remove this and insert this rubber band onto this pulley and again take it here. So this is the thing one should not forget, and keep these two bushes from both the sides, and this rubber band will go from this pulley to this pulley, and check that when you are moving this, only spoke is moving. You can see this bobbin is not moving, but if you can see, this spoke is moving. So we are giving this mechanical energy to from one pulley to another pulley. So this is completely ready. Now we have to fix two magnets here in the middle. In what? So first of all, see, these are two disc magnets. Make sure that they are attracting each other. If they are not attracting each other, remove this tape and put it on another side in such a way that they should attract each other. Otherwise, if you see it upside, turn it back, they will repel each other. So this is the attraction position. In this position, remove the release paper and keep this release paper onto the spoke here. So it should go in the middle, it should not touch the bobbin. So I am not sure if you can see clearly. So this disc magnet should not touch any edge of the bobbin, because this is going to move freely inside the bobbin like this. So if it is not, see, for that what you have to do, this side it is free. See, you can see it free clearly. But when it coming from the bottom side, it is touching the bobbin. So if it is touching the bobbin, it means that you have to change the position a little bit. So in that way, shift the position of the magnet and again try it. Now you can see clearly this is moving freely inside this. In this way, you have to adjust the disc magnet. And after this, from another side, we have to fix the magnet in the attracting position. For that also you have to be very careful and then press them both and see. Now if I am moving this pulley, here it is obstructing, it is not moving. So it means that you have to change the position of the magnet little bit. See, this is wrong. This bobbin should not move with the spoke. It means that magnet is touching somewhere and it is making the bobbin to move. So adjust the magnet in such a way that now you can see only magnets are moving. I will show in this position. Only magnets are moving and bobbin is steady. Now I will not hold the bobbin as well and show it to you like this. In this step, we have to fix these 4 LEDs onto this plastic strip. Make sure that you are connecting all 4 LEDs in parallel. If you see any LED, it has 2 legs. The longer leg is positive and shorter leg is negative. So what you need to do is, these are 2 aluminum foils. So keep this foil, half of the foil on one edge and fold it. like this. So you will see this foil is not covering this hole, but from the bottom side it is like this, and from top side it is like this. Similarly, you have to make another foil in this. So I am just removing it meanwhile. So once both are ready, we can keep both the aluminum foil like this. Now we have to connect 4 LEDs in parallel, but make sure that, suppose this is the LED. Now if longer leg is this, I am putting longer leg in this hole. So in future all 4 longer legs will come on this side. So insert this LED, twist the leg of the LED and take it on the top like this, and this leg also. Now you cannot tell which is positive, which is not negative. Only you know prior that you have kept positive leg on this side. So when you are connecting next LED, make sure that you have kept positive LED on positive leg of the LED on this side. So I am just inserting 2 legs again here. Take it from the bottom. Make sure that these legs of the LEDs are touching this aluminum foil properly. There should not be any loose contact. Again insert the third LED. Take it from the bottom side and fold it on the top side, and the last LED like this. So this LED assembly, these 4 LEDs we have connected in parallel. Being this aluminum foil is a good conductor, it is giving these all 4 LEDs are connected in parallel. Now take this wire, remove the insulation. You have to twist this wire, all the metal strands. Remove insulation from another end as well. Hold the metal part of the wire and twist the wire. Similarly, you have to do it for red wire as well. After this, take any one wire. Say red wire I am connecting to the positive side, but this doesn't matter which wire you are connecting to which side. Normally we take red as a positive and black as a negative. So connect this wire with the legs of the LED and twist it like this. After this, you will remove one both side tape, release paper, and stick this there like this. After that, we have our structure ready. Here these 2 wires will go towards this side. Now I am just removing this release paper from it and keeping this at one corner. Now we have to join 2 wires coming from the bobbin. Make sure that you have removed the insulation properly. Now take these 2 wires, the part from which you have removed the insulation, hold it with the black wire and twist these 2 wires. Later you have to put a cello tape on it. Similarly, take another wire, hold it in such a way that you have removed the insulation from the first centimeter and connect these 2 wires. Put a cello tape on both the wires. Now it's time to see working of AC generator. Here magnet is moving inside the coil. So when I am moving in this side, you can see LEDs are glowing. If rubber band comes out, you have to put again on the pulley, on both the pulleys. Now what will happen if I turn it opposite direction? Still LEDs are glowing. Being AC current is generated, so it doesn't matter in which direction you are moving the pulley. As this is DC, this is not DC current, this is AC current. So direction doesn't matter here. But when you see a regular dynamo, in that DC current is generated. So in only one direction you get current, in another direction you don't get current. So this is the working and function of AC generator.